Thank you for coming out today for this forum. I think all of us knows that one of the biggest things in Taiwan this year is we joined the world to unveil the roadmap of net zero 2050. And I think on the ways to net zero, technology play quite key and crucial roles. And our government have just launched net zero technology actions. We aim to a few breakthroughs on the hydrogens, smart grid, storage technology, and renewable energy. We know on the path to the net zero, we need more to learn more things, and there's multiple challenges ahead to tackle. So actually, we just invite some prominent international innovator and net zero pioneer to bring us their latest knowledge, insight, or develop on how they contribute to their part to a cleaner planet. So actually, we just one of the prominent speakers just arrived here and to give his thoughts on how to do the clean energies to achieve the net zero, which is energy vault from Switzerland. And I would like to do some little introductions about the Energy Vault. And Energy Vault is a company based in Switzerland, just like I said before. They are the teams of energy industrial experts, aims on decarbonization of reducing the cost of clean energy, and also delivers valuable grid-scale energy storage solution. So to have we all know that to have a green future transformation on conventional grid is inevitable, and it's a big challenge. So we just invite the Energy Vault to give us their thoughts on how the clean energy can contribute a cleaner planet. So just let's give a big applause to welcome the chairman of Energy Vault, Mr. Jung, to give us his thoughts on clean energy. Please.
Hi, everybody. My Chinese is not very good, so this overview will be provided in English. But I want to begin by thanking Dr. Liao and everyone at Future Tech that gave us this opportunity to talk about how we wish to contribute to this wonderful transition that's happening right now from fossil generation and sometimes coal, gas, but also nuclear generation into so-called intermittent resources, right? Wind and solar. The interesting thing, in addition to the decarbonization goals that we all have, and I personally live in San Francisco, California, and Tokyo, but everywhere, every country, Western Europe, Switzerland, other places have the same challenge. But we're trying to accomplish this challenge on an electricity grid that's over about 100 years old, but there's no inventory control. I mean, you can't stop electricity. It moves at about the speed of light. It doesn't matter if it's direct current or alternating current. Electrons are pushed at the speed of light. So energy storage is not just important, and I'm here to talk about a very interesting gravity technology that replaces over 90% of the install base of energy storage in the world, and that is pumped hydro in a much more sustainable way. But I also want to focus on the problem that we're trying to resolve. It's not easy, but hopefully together we can do it. So the presentation that we prepared will just give you a little bit of background on the company. Secondly, our technology, what we provide, including in places like Rudong near Shanghai, where we're implementing a 100 megawatt hour system right now to be ready in the second quarter of this coming year. And then talk about actual implementations, right? It's one thing to kind of talk about PowerPoint. It's another thing to talk about, why in CAISO, ERCOT, in the United Kingdom, in Scotland, or in China, and hopefully in Taiwan, requires some of this technology. So I don't expect you to read everything, but we are a publicly traded company. So we went IPO on New York Stock Exchange February 14th of this year, which is Valentine's Day, which means that as opposed to a private equity-based company, we are a public company, and therefore there's a number of perfunctory disclosure requirements there. So just to give you a little bit of history, we are doing a lot of wonderful things. We, as a company, just announced 495 megawatt hours worth of short duration energy storage, and that is usually based on batteries, because one of the first things that you need to address with a grid that's transitioning to wind and solar is variation of frequency and voltage. That's one of the first things that you do. And eventually, we see a lot of grids that have a certain minimum penetration of intermittent resources requiring our proprietary long duration technology, which I'll talk about in a minute, including how it works. How does the 9.81 meters per second square actually work? We're backed by a very good group of customers and investors. They include the largest, I think one of the largest companies in the world, which is Saudi Aramco. It includes the likes of BHP, one of the largest mining companies in the world. Korea Zinc is the largest zinc producer. They operate in Queensland, Australia. And Al Green Power is one of, if not the largest independent power producer / utility out of Rome. So we have a lot of support to accomplish many of the numbers and many of the results that are featured here, which I won't go on. But needless to say, because we did an IPO, we ended the second quarter of this year with about $300 million on our bank account, US million dollars. So we have a lot of money. We have to manage a lot of working capital that goes up and down based on what we order. But right now, we're focused on not only the Chinese market and Southeast Asia, but Australia, North America, and also the European Union as well. So one of the key things that we're focused on, very much like what Dr. Liao mentioned, is decarbonization. That is important. And we believe that decarbonization is accelerating because the cost, the levelized cost of energy on solar energy, including wind generation, gets cheaper and cheaper every year. Yes, there's some supply chain ups and downs that occur. We're living in a very global supply chain environment. However, because of this law called the Henderson curve or the learning curve, every time you produce more units of a thing, it lowers in cost. Very much like semiconductors and silicon chips. We call it Moore's law, but most manufactured goods like solar abide by this. And what's interesting about solar is the sun is approximately free. You don't need fuel. And so, if Germany can have such a big impact on the solar industry, I'm sure the rest of the world that has some of the best radiation on the planet can also benefit. So in a summary, we as a company are a technology provider. So we work with owners and operators of power plants, right? They can be fossil power plants, coal, gas, oil. They can be renewable power plants, wind, solar, tidal is another example. But we offer two different technologies to utilities, developers and independent power producers, and large industrial companies like Korea Zinc, who are in the metals and mining or data center industry. So we offer our proprietary long duration energy storage technology, which we like to scale about 8 hours. So that is when we do the economic modeling to see if it makes sense, typically the average is about 8 hours. But we're also providing short duration energy storage technology. So last year, the world implemented about 28 gigawatt hours worth of energy storage around the world. That's just a statistic. In terms of gigawatts, it's about 12 gigawatts. And most of that capacity was battery-based energy storage systems because most of the world is trying to balance intermittent resources, which are oftentimes not centralized generation, it's distributed generation. So our grid was really designed for centralized big generation. So we're making a lot of changes to the grid. And one of those changes is deploying energy storage. And of course, as important as the hardware, the software is something that we don't talk about as much on the electricity grid. The grid, all 7 terawatts globally around the world, that's about the maximum generation capacity of the grid around the world. The US, as an example, is about 1 terawatt of maximum generation capacity. California is about 80 gigawatts, or 0.08 terawatts, just to give you a sense for it. So what we do with the software, we, number one, ensure that our energy storage system, whether it's long duration, short duration, delivers and is dependable, reliable for as much as 30 years for the gravity technology. And what the use case is, but battery-based technologies oftentimes rate at about 5,000 charges before they deplete to about 80% of their usual life. But in order to maximize the functioning of energy storage, you need the software. Secondly, our software orchestrates a lot of other equipment, not just P and Q commands on the gravity technology and the BMS and the bidirectional inverter through a PLC-based controller. It communicates with medium voltage, high voltage transformers. It communicates with substations. It communicates with other forms of generation, both renewable and fossil generation. So it orchestrates not just our system, but the entire grid. And the same team that's delivering this technology was responsible for delivering over 100 utility scale systems in 12 countries. A company that I founded prior to Energy Vault called Greensmith Energy that in 2016 did about 1/3 of the megawatts in the United States, more than Tesla, GE, AES combined, and did that with 100% safety track record. So the software is the kind of software that is so-called RIG certified, which means in CAISO, which is the transmission operator of California, Remote Intelligent Gateway certified. So if you want to get paid in California, you can be on this kind of software. So one of the strategic positioning of Energy Vault as a company is that we're unique in the sense that we're the only company that provides not only both long duration, short duration technology, whereas right now there's a bifurcation of the market where you have Tesla, Fluence, Wärtsilä, Powin that do system integration, right, battery-based integration, and then you have long duration technologies such as ESS and Form and others. We're the only company that has both in one company. And the reasoning for us is because we don't want our customers thinking about what kind of duration, what should we do, should we use a battery, should we use pumped hydro? Should we use EVX from Energy Vault? We want to take on that responsibility and give them the best answer that not only solves their technical problems, but does it in a very economic way from a levelized cost of energy standpoint or levelized cost of storage standpoint. And so we expect these customers to treat us not as just equipment providers, but really as partners. And that is the part of the reason we're there. We also provide software, as I mentioned. So anyway, just wanted to summarize strategically where we're positioned as a company. So we have a lot of senior executives in the company. Unfortunately, my face is up there, but we also have people from telecom industry that founded companies such as O2. We have people from Danaher. So we have a mix of startup individuals who are used to beating some of the biggest companies in the world. And then we have a lot of large companies, successful executives that know how to build this company into something that's going to last for the next 10, 100 years. So this is our history, I suppose. So we took SoftBank investment. We commissioned our crane-based system, which is our first product set you can think of, in what's called Castiglione, Switzerland, near Lugano. So you fly into Milan, you cross the Swiss border, and you're there. And so we got a lot of feedback with that system that, again, was built with SoftBank investment. And that is from the largest utilities in the world. So one of the feedback that we got is, can you make it shorter? not so tall, so that we can get it permitted in a lot of different parts of the world. 2, can you actually give us the flexibility of tailoring the power and energy in a way that makes sense to us? Because no two power plants are the same, as we know. So they wanted that flexibility. 3rd, and what you can see here, it's called EVX, and there's a nice animation, but it's more like a building with elevator banks, if that makes sense. So it still uses the gravitational principle of 9.81 meters per second squared times the mass times the height. The masses are, right now, the minimum is 25 metric tons each. And sometimes you can have hundreds, if not thousands of these metric tons, right? But they go up and they go down. So they go up when you need to store energy, if that makes sense. And they go, so, gravity times the mass times the height. And then they come down at half mv squared kinetic energy when they need to inject more power into the grid. So energy arbitrage is the use case for it, but think of it very much like energy arbitrage, which is the main thing. So when you have too much wind or solar, you can store it, and then you can release it when you don't have enough, like at nighttime and other times of the day, or maybe when you turn on all the air conditioners when you go home, or you go into the office buildings. It's a nice way to arbitrage a lot of intermittent generation and create that inventory control that simply doesn't exist. And of course, we also launched our battery-based energy storage division, which is part of my responsibility from a company that I mentioned earlier called Greensmith. So just to give you a sense, this is an example of charging and discharging and some of the feedback that we got. And right now, as I mentioned, near here, you'll be able to go to Shanghai and see a system to the tune of 100 megawatt hours. It's a 4-hour system, that particular system, so it's 25 megawatts, 100 megawatt hours, but we expect, together with a partnership that we have with CNTY, who's a publicly traded infrastructure company in China, to deploy a lot of these systems. We just announced potentially deploying 2 gigawatt hours worth of gravitational energy storage in Inner Mongolia that has some of the best wind assets, except if you're looking at the wires, the transmission distribution infrastructure, the investments are simply not going to catch up with it. So what you can do is put energy storage so you can smooth out basically the energy and power that you need at different times on the day. So this gives you a sense of the scale. It's a very large system. It's not a small system. My team was responsible in 2016 for building the world's largest energy storage system, but even that is smaller than this. This is a very large system that's as high as 147 meters at the standard deployment. So it's not meant to be in Midtown Manhattan anytime soon, 100 kilowatt box. It's really meant to be near wind farms, solar arrays, coal plants. And that's one of the things that excite metals and mining operators like Korea Zinc and BHP. That is, the mobile masses have a very big ability to remediate coal ash and mining tailings, which I'll talk about in a second. This gives you kind of a sense for the scale of the system. And what we're doing is we're actually innovating not only on the technology that we have to deploy, but the machinery to make the technology, if that makes sense. So one of the benefits of our system is that we're not shipping hundreds of 25 metric tons around the world. They're made locally. So, I'll give you a good example. The mobile masses, the default material that you use is excavated soil. So the same site that you would implement gravity-based energy storage, you're excavating a lot of dirt. And we have a global partnership with Cemex, which is one of the largest cement companies in the world. And they have an adhesive that allows us, regardless of the soil composition, to make sure that things such as torsional rigidity is maintained on the mobile masses, because we guarantee these systems for 30 years. So it's not a very short period of time. So we do a lot of innovation to have, say, brick making machines. And so if you think about Samsung SDI and how they make batteries, and I've seen many of their battery factories, they innovate on the machines that make the machines. And that's basically what we're doing here. This gives you a sense of some of the remediation. So how much remediation are we talking about? As much as 25% or more. So in some cases, depending upon the composition of the coal ash or mining tailings, it can be in excess of 50% of 25 metric tons each, right? So this gives you an example. So the fiberglass associated with wind turbines, as there's a lot of repowering going on of wind farms around the world, you put them ordinarily in landfills. I mean, that's not a very good sustainable answer for removing a lot of waste that basically fiberglass never goes away. It'll last a lot longer than us. So the mobile masses is a great way to imbue coal ash, mining tailings, and fiberglass from wind blades into the mobile masses. And that's why metals and mining operators are so interested. So let me talk about the other aspect of what we offer, because again, we want to be a one-stop shop energy technology company that customers don't have. So right now, if you're a utility or an IPP or even a large industrial, you're thinking about, okay, do I need this battery, this size, this ratio between power and energy? Do I need long duration, short duration? We want to be the company that comes to them with the best answer because of our experience and because of our agnostic orientation, which means we don't really care, other than our proprietary gravity technology, what kind of batteries go into our battery-based energy storage system. Could it be iron phosphate cathode? Could it be NMC cathode? Could it come from Taiwan? Could it come from China? Could it come from the United States? Could it come from Western Europe? So that flexibility is very hard to do. However, given that the same team integrated 16 different batteries across the 100 systems delivered with a 100% safety track record in 12 countries, including, by the way, not just lithium ion, but vanadium redox flow batteries, zinc bromine flow batteries, aqueous ion batteries from a company called Aquion. So as long as you have the right experience, you can deliver that totality, which, by the way, includes hydrogen equipment as well. So we expect to announce a system win that'll be the largest green hydrogen system that's implemented for backup in the Napa area. Napa is the winemaking, kind of expensive real estate area north of San Francisco. So the software does three things, right? So number one, it has integration through Modbus, CAN bus communication protocol. So if you think about the grid, there's a lot of different equipment, but they're all on different communication protocols. However, if you're going to optimize everything, you need to communicate with a lot of different pieces of equipment, which in some cases include transmission operators, independent system operators, and others. So CAISO, ERCOT, PJM, MISO, just as an example in the United States. You need to exchange signals. And this exchange is quite difficult. PJM gives you a Reg D signal for frequency regulation every 2 seconds, 24/7. So you need the kind of software that can use that. Not only that, AI is used a lot, right? Like terms like reinforced learning. We're literally talking about applying small data and big data. Good example of small data is weather forecasting, so that you know how much solar is going to be produced based on radiation forecast, or how much wind generation there's going to be. Otherwise, how do you know how much you should charge and discharge your batteries as a function of the particular electricity market you're in, and who you are, and how you make money or solve an issue? So this optimization equation is the application of what I call small data. Big data is more associated with reinforced learning, where you look at different states within the Australia electricity market as an example, and even if your energy storage system that you deployed in South Australia near Adelaide made a lot of money, you ask the question, if you had a time machine, would you do something different? Would you have a different weighted average use case? And so that's a very important aspect of the software. Of course, the software also allows you to do different applications, very much like Microsoft software that you get, where long time ago, I remember you turn on, turn off different features, depending upon how you wanted to use Excel or Word or PowerPoint. So this software is one instance, but it allows you to turn on, turn off different applications, which are essentially algorithms, because frequency balancing is done differently in the FCAS market in the United Kingdom after National Grid rewrote the ancillary services rules versus the various ISO markets in the United States. It's done very differently, also in Australia, China, and other parts. So that just is one type of functionality that's done differently. But if you multiply that by grid forming, in terms of creating a microgrid or energy arbitrage, or hybridizing with renewable generation in terms of energy storage, there's a lot of use case applications. So based on, let's say you use 4 applications for the California market to make a lot of money, when you add up the 4, that's basically called a use case. 4 applications for 1 use case. And we also want people to change their mind. The electricity industry is very much one where you take a 10-year snapshot, 20-year snapshot, and then you're finished. What we want is for people to think about, okay, I'm going to need this much battery, this much hydrogen, this much long duration energy storage, and then next year I'm going to need something different. I'm going to need more energy, more power in terms of inverters, more long duration energy storage, another row. So we want the ability for the grid to be as nimble and flexible as our data centers. If we think about cloud computing, it's almost instantaneous. It doesn't matter if it's private cloud or public cloud. You have the ability to choose what you need and to optimize it. On the electricity grid, you really do not have that choice. So we want to be the kind of company that brings that choice to utilities, grid operators, developers, IPPs, and then large industrials. This gives you a sense for the battery-based energy storage system. And what's good about it, and very different than a lot of our competitors who are more, I would say, product-based companies, is it allows you to mix and match different components. So if there's a problem in the U.S. and a lot of people are vying for Inflation Reduction Act, and they want to make batteries in different places, it allows you to not be. It's kind of like the way Tesla had chipsets that allowed them, from an electric vehicle standpoint, to be a lot more flexible and hit their quarterly targets in terms of vehicle sales, whereas traditional automotive OEMs had an issue because they had a chipset that they absolutely had to use. So the average internal combustion engine has about 1,000 chips. So electric vehicles, you can imagine, it has a lot more chips than that. So Tesla was one of the only companies that not only controlled their software, but it allowed them to change their chipset as a function of where the supply chain constraints were. So those are some of the advantages that we want to bring. So a good example is one of the awards that we got for over 200 megawatts in a place called Stanton, California, was with a company called Wellhead, who's a developer company. They've done a lot of systems in California. And the reason why we beat one of the largest competitors in the world for energy storage is because we just simply managed to make Wellhead more money using that site. And that's it. So we're a solution company. We have a product platform that allows us to get down the cost curve, but we also have a lot of experience so that we can be flexible about the equipment that goes in. So I talked about that. These are fancy slides that take a little while, apparently. Okay, there we go. And then I'm gonna save you. So we're a relatively young company that was founded about 4 years ago, so not that old, especially compared to our competitors. But these are some of the numbers around systems that we expect to actually deliver. The earliest COD delivery date is April of 2023 in Rudong, Shanghai. And then we also have other June, July 2023 CODs for the 495 megawatt hours worth of awards that we received across 3 systems, one in ERCOT, which is Texas, 2 in California, from Jupiter Power and Wellhead. And we also expect another more than gigawatt hour worth of announcements, hopefully, before the end of the year on the battery side. And then, of course, hydrogen. It's a very interesting use of hydrogen, which for me is another form of energy storage. I mean, that's all hydrogen is. In this case, it's for backup power for Napa, as I mentioned earlier, where there's a 48-hour requirement to support load. When you have brush fires in California, you've probably seen them on TV, or you've been to California, you've seen that the earth is getting hotter and hotter all the time. So thermal, events happen all the time, which creates a lot of de-energization of distribution feeders for large utilities in California. So this system that has 1 hour of modern energy storage for grid forming, microgrid development, also accompanies 47 hours of green hydrogen that can then power fuel cells to inject electricity into the grid so that the local city can operate for 48 hours while the local utility gets the line back up, if that makes sense. So it's kind of a backup application. The Inflation Reduction Act is kind of important for some of our customers that are based in the United States. And there are a lot of great things. There's a $3 per kilogram subsidy for green hydrogen. There's a subsidy, finally, for a standalone energy storage. That didn't happen. Before, you had to basically store solar generation at 80% or more in order to get basically investment tax credits. Now, solar developers also get the choice to move from ITCs to investment tax credits to production tax credits But what I wanted to mention is not just our care as a company that receives these tax credits, but our customers who may receive these tax credits. They expect their partners, their technology partners, to be well-versed in these technologies as well. So we are working with Brownstein and other law firms in Washington, D.C. and other parts of the United States to make sure that every aspect, including prevailing wages, which is another aspect of implementing our energy storage systems, is covered so that our customers can benefit, even if we don't directly make a single penny. This is just a chart that you would have seen around duration, and we feel very good about where Energy Vault is. And I believe this is the Rudong site. The interesting thing about the Rudong site is that the soil is very wet. It's very marshy. It's not bedrock soil, which is what you would find in places like Australia and Manhattan. So we had to put over 1,000 pilings, which is basically rebar into the ground at some depth. And they have 3,000 employees on site to implement our systems very quickly because cost of labor is relatively inexpensive compared to Western Europe and North America and other places. But we're very excited about this system. Our partnership with CNTY, who's an owner behind a $50 million investment that they made during our IPO through Atlas Renewable out of Houston. It's a Neil Bush company. Eric Fang is the CEO of that company. But we're very excited. In fact, I'm going to Tainan tomorrow to meet with the mayor to look at an industrial site for the implementation of our technology to see if it makes sense at what size. So I'm pretty sure my time is coming up pretty soon. I just wanted to check that whether I'm around 40 minutes or more. How much more time do I have? 5 more minutes? 10 more minutes. Okay, wow, I'm faster than I thought. So the US, where 1 out of 7 electrons are pushed, right? So about a terawatt of generation. Texas is about an 80 gigawatt grid. California is about an 80 gigawatt grid. For instance, PJM is composed of about 5 different states. It's the largest wholesale market in the world at about 160 gigawatts outside the European Union. So it's a very large, organized electricity market. So our 2 customers that I can speak to, Jupiter and Wellhead, operate a lot of facilities in these markets. And so if you think about why an independent power producer would deploy energy storage system, there's only one answer. It's to make money. It's just like how solar plants get built, how wind farms get built around the world. It's always to make money. So in other words, these power plants need to be equity financed and debt financed to be built. So very, out of the 28 gigawatt hours worth of energy storage that was implemented last year, none of those systems did not have financing behind them. I'm talking about the JIRA, JICAs of the world, the World Banks, the Macquaries, a lot of financiers that are involved in supporting. And indirectly, some of the largest funds in the world are also supporting so-called ESG funds like BlackRock, which is the manager of the largest fund in the world. So, I mean, this is a good time to be in this space of transitioning because there's also a lot of support and there's a lot of money available. So coming back to Jupiter and Wellhead, the reason why they selected us is twofold, right, predominantly. One is, in spite of the fact that we're a young company, they trust us to deliver, right? So if you have a fire, which you had at Moss Landing, the site of the world's largest energy storage system, which is just south of San Francisco, I believe Fluence and Tesla deliver these systems. It's not good. It's not good for the company. It's not good for the industry. Thermal runaway basically means, fire. So it can be dendrite formation and shorting of pouch-based cells. It can be caused by fire suppression systems. that drown out, all the battery capacity and possibly inverters. It's a system of systems technology, right? So what I mean by that is when you put together a system, and it could be an iPhone, it doesn't really matter. I mean, it's very interesting that Apple doesn't manufacture most of the components. They understand design, they understand integration, and they work with a lot of companies. So energy storage system is a system of systems so that if you have a bad battery, or if you have a bad camera, if you have a bad chipset, it's just simply not going to work. It doesn't matter what fails. Anything fails, the HVAC, the fire suppression system, the distributed computer, the enclosurization system, one of the battery modules, one of the battery cells, the bidirectional inverters, one of the quadrants of of an inverter that provides all 4 quadrants. It doesn't matter what fails. The whole system is not going to make money for these customers. So number one, they trust us to deliver. So I think that's very important, and based on a lot of experience in an industry that still struggles with thermal runaway events. The energy capacity that's contained in a battery is very high. I don't think we realize, we talk on our phone, how much power goes inside this small little device that all of us have in this room. The second reason is that based on our agnostic approach. So agnostic is a word that I use, but it means literally, it doesn't matter what equipment, we know how to integrate it for you to solve technical issues in an economic way. So as long as we're making more money for these customers, they're going to choose us. And this is why I believe the guidance of another publicly traded company, which is called Fluence, is about $1.1 billion in 2022 on the revenue side. And we're growing very, very quickly is all I wanted to say about that. That's about it. I just wanted to make sure there's a little bit of time for Q&A. But again, I want to thank Dr. Liao, the Future Tech sponsors. I spoke at SPI, Solar Power International, where you have about 5,000 people. It's a very large conference in Anaheim near Los Angeles. And might I say, everyone is very eager to get out because we've been trying to manage a pandemic, some better than others. So again, thank you for listening. And if you have any questions, there's a lot of material on our website, energyvault.com website, very much like Bank Vault, and also on YouTube. If you type in Energy Vault, you should get the latest video that shows how our gravitational technology, which we call EVX, actually works, and what kind of scale that you can expect. But I'm also happy to answer any questions. Thank you very much.